have to share your video, and I'm not recording video of you, although your tiny image may show up on the side of the screen during a recording. If you don't want to throw your voice into the recording, again, I don't mind if you use the chat, but don't hesitate to speak up if you want to ask a question. You can share video, or you could just create a still image. I generally can't keep my eyes on the camera, so I usually put up just a still image after a few minutes here. But back to sharing my space. There's a pad of paper that I just got my phone pointed at. So this will be an easy way for me to write stuff down for you. And what I'll do, besides recording the video of the session, whatever we write on these papers, I will scan that and post it as well. So if we wrote an answer to a problem that you wanted or something like that. So I will scan these notes at the end of the session too. I got another camera pointed at a whiteboard on my basement wall, and I think I'll find some use for this sometime. I don't think I'll stand in front of the whiteboard and talk at you, because you can't talk to someone and write on the board at the same time. You're just not facing them. But I might record problems that you'd like to see. You know, like here's a problem from one of the sections we're talking about this week. You know, it'll be a great demonstration. Maybe I'm going to make a recording of it later, and then I'll link to that recording on our website. So more about our website in a few minutes. So that's just a whiteboard in my basement. This part is me. Hello. And you can see the basement pipes in the background. Again, I'm not asking you to share video. I'm rather careful about privacy concerns as well. Just in general, I'm just cautious. So usually I just put up a picture of myself or just one cute image like that. So let me go back to the paper, because that's going to be the main space. Yeah, we'll get into that, and thank you for that comment, Lily, because you learn by imitating. You learn by imitating me, you learn by imitating the book. I really like the approach and the attitude of this book. And when you get into their system, you see that they have a lot of videos for you to watch. And you watch and you see and you hear an explanation, and that gets into your brain a lot faster than reading, although you do have to do a lot of reading. So I really like the attitude of their book. I've met Mr. McCaig a couple times and really like the projects that he's doing. That's why I chose this book for our class. So you, and we'll get into this, you're going to help me, because in a classroom, we got all kinds of advantages. I can look at your faces. I can see the happy face, sad face, quizzical face, sleepy face, agitated face. I mean, you get a lot of cues from talking to people, right? And I don't get any of those cues right now, even if you were on the video. Very hard to see those things. So, that's a great question. I'll answer that in a second. So you have to send me the information you need. You know, want to see a solution to problem 41? Send me a note, and I will create the solution, maybe write it on a paper, maybe do a video of it, and post it to our website. More to our website in a second. How do you see a close-up of the whiteboard? That's a really good question, and it might depend on me being the host and you being the guest. But I think if you play around with the view at the top, the gallery view or the speaker view, if you click on the whiteboard, if you double click on any of the boxes across the top with your names or my name, then that becomes the prominent box on your screen. And you might just have to experiment with this. You can't damage anything, so don't worry about that. But I double click on my little whiteboard square, and then the whiteboard is being recorded. I double click on my paper, and then my paper is being recorded. So I'm gonna keep track of wherever we are and keep that focus on the paper, the whiteboard, or my face if necessary. Usually on the paper because we can write things pretty fast on the paper. Okay, good deal. Yeah, this is a very strange situation, isn't it? And so this is new to me, even though I've done it since March, and it could be to you in that sense as well. In March, the situation was if you were in school, wherever you were at school, everybody, kind of knew each other because they had worked, teachers, students, everything for, 6, 7 weeks, maybe more. And then oh, hurry up, go online. And, but you had some relationship. You had some understanding of them. In the summer, I taught a class, but it was very fast class, very focused, just 7 weeks or 6 weeks. That helped get everybody on the same page. Now here we're doing this from start to finish online, and I have never met any of you. And maybe I'll never meet any of you again. My loss, I would rather talk to you face to face because it's just easier. I'm all about trying to make things easier to learn, easier to perform in the class. That doesn't mean there's no hard work involved. It just means I want to show you the fastest way to do things. Sometimes the fastest way to do things is through a lot of hard work. So even if I've been running the Zoom meetings in 2 previous semesters, this is the first time I'm running it, start to finish with 20 people I hadn't met before. So getting together as a group, that's not simple. But I hope you feel comfortable to ask questions written or out loud anytime during the class. And as you go along, you might feel more comfortable. I also have office hours, and we'll poke into those now as we look at the syllabus. So another thing I don't like to do, but it's going to happen today, and that is I'm talking at you, just trying to orient you in our space, orient you on our website, orient you on our course. Because this is my experience, after I do that, after you got a feeling for the system I'm using here, a feeling for how I'd like to do things, it is going to make you faster. It is going to make you better because you're just following, a system. Systems don't solve problems for you, but they give you a rhythm. So let's take a look at the website. I just pop over and share my browser. And now you see the browser in the window in front of you. And I can make the text a little bit larger. And that'd be a little bit easier to read perhaps, but you could be viewing the browser on your own computer. Okay, here's the deal. So I have linked you to this homepage. This is the homepage of our course. It's not glitzy. It's not got firecrackers and pictures of cute puppies. It's about math. And again, I'm very utilitarian. I just want to give you what you need. What you need is not puppies. What you need is videos of how to do problems and instructions for how to do problems. So I just want everything to be organized. I want you to know where you are at every minute. And I gave you this link a couple times before class started, just a little introduction to what our class is, a little introduction to our textbook, and I'll show you more of that later, and some other items here like office hours. So I am available outside our class meeting time. And I've sent you invitations to our class meeting time, but notice I only sent them for the first 2 weeks. I just want to make sure everybody's on the same page. Everybody was working with a calendar the way they wanted to. So for the first 2 weeks, I'll send you the calendar invitations. I already did. I sent you a cancellation for Tuesday, September 8, is it? That's right. 1 week from today, it's a Labor Day break. We're not meeting. After these first 2 weeks go by, if everything's going smoothly, I will send you the calendar invitations for the rest of the semester. But I will not send you calendar invitations for these office hours. These office hour links that you're looking at in front of you right now, Monday, Wednesday, 11:30 a.m. to 12:25 a.m. See, typo, 12:25 p.m. Okay, I'll fix that. These are just links that'll take you directly into the office hour. If you click on this at those times, you'll be in a Zoom meeting with me and whoever else is handy, just not reproducing what it's like to visit my office. I wish you could, but just visiting virtual office hours. I won't record those office hours video because people are just popping in and out, ask questions. I will scan any notes we make. If people are asking me a question about a problem and then they want to go back later and see that problem again, I will scan the notes and put them on my website. Okay, next step. And I do apologize for all the little tiny things I got to show you today. In these next two buttons here, you see a Math 119 questions folder, a Math 119 assignments folder. Sometimes you want to send me a question, but you probably know it's a royal pain to type it into an email, like you can't make exponents, you can't make this, you can't make that. It's hard to type math into an email, although I don't mind if you do. So if you're just writing on the piece of paper, you're doing a problem and you say, whoa, this is not working, something is wrong. One of the simplest things you could do is snap me a picture of the paper and upload it to this Dropbox for questions or later for assignments when you want to hand in a written assignment. So all you do is click on this folder and you can select a file from your computer or device. I'm just going to pick some little picture right here, nothing serious. And then you just enter your name, enter your email address, and the cool thing about this is uploads, lands in my mailbox, and you get a return receipt here. I mean, you get a page that says you are done. You did this. And I get the email with the time on it that tells me when you handed it in. So yeah, there are deadlines everywhere. But I know when you handed it in, you know you handed it in. We're all okay on that. Maybe some other day I'll show you how it lands in my email box, what it looks like. But it's kind of a convenient service. And particularly if you're writing something on paper and you don't want to spend 30 minutes typing it into an email. Snap me a picture. Make sure you print clearly, boldly, readably, got some good light when you snap the picture so that, I can read it. But this is a decent plan right here. We'll talk later about handing in a written assignment, and you can use the assignments folder here for that. After that, on our homepage, you see an outline for every week. Now I've listed 16 weeks here, 15 weeks in the semester. But you got a half week next week, Labor Day break. You got a half week at Thanksgiving, which is week 13, right here. So I just said that's 16 weeks on the calendar, and I just chopped them up as calendar weeks. You see, we're looking at, 3 or 4 sections, often 4 sections a week. Looks like predominantly that, except, the half weeks. Here's an exam and review time schedule in week 8. Here's an exam and review time schedule in week 16. We'll talk in more detail about the exams later, not right now too much, but now you know when they're going to be, basically. Let me see what else I can say here. Every time you click on one of these, you get the outline for that week. And the same if you clicked on any one of the weeks up here. So here's week 1. Here's the outline for week 1. Here's the homework for week 1, handouts, video, technology, exams. We'll go into the syllabus and show you what kind of technology we can use. Desmos, TI-84, those are good enough for us totally. But if I want to show you something in Desmos, I can send you a link to it under the technology section. And I don't have anything there yet, but I'll give you a demo later. Okay, what we have here, and then we'll go to the syllabus and others, is the outline for this week. We're going to look at 4 sections this week, basically. And here are the objectives from the book. We could add more notes, but these are the main points in the book. Notice I pick out these recommended problems here. I'm never going to say to you, okay, everybody, let's do 1 through 130 odd. Because, you know, that is a time drain a little bit. What I do in every section is picked out 10 problems. 10 problems that I said, those are representative. Those are key. Those are good problems. If you're comfortable with that, you're on the right track. You're going to also do some problems on the XYZ homework. But the only thing I think the XYZ system is really nice, but filling in boxes is not solving math problems. You need practice writing and reading and explaining to people. So that's how I want you to use these recommended problems. Do you notice that some of them are links? So for example, I got a double comma here, right? Okay, so sometimes I'm typing too fast. If there's a link right there, that just means I posted a solution to that problem. And then you go to this Google Drive, got some recommended problems. Section 2149, was it 2147? 2149 right there. So this is what I mean when I say, if you send me a note and say, I'm not sure about this problem, you listed the recommended problems. I want you to concentrate on the recommended problems. You can do as many other problems as you want, but concentrate on the recommended problems. If you have a question, send me a note. I will write down how I would do it. You could do it better. You could do it shorter, longer. But generally what I write here is like I'm saying, this is a good explanation. Don't want it to be too short that I don't see what you're doing. You are explaining to someone when you're showing them an answer. You got links to written solutions like this. I just put up some samples this morning. And maybe, like I said, maybe one of these links will be a video tomorrow, right? If I want to test out the video making, mostly because it'd save a lot of handwriting, and I write a lot. Your hand gets tired after a while. If you don't spend too much time making videos, you don't go into like cutting and pasting and trimming and editing out the sneezes. You can do a video relatively fast. You guys create videos just for your personal interests along the way, I'm sure. Why do I get this like double comma disease? I'll figure that out later. See double commas everywhere. Okay, so after that, here comes some homework. You have the XYZ homework working in the system, and you have a written homework. And here's the logic. The XYZ homework, I want you to practice just doing basic things many times. And some of the problems they're very good problems. So this is a good way for you to just practice doing computations. But just telling me the answer is not good enough, or filling in a box is really not good enough. You have to learn how to explain things to people. So once a week, I'm going to pick out a problem, from the book, or maybe it's from the book, but I changed something, changed a number, changed a drawing. And it's not that I'm trying to pick out a problem that's easier or harder. I'm picking out a problem that I want you to just write a nice explanation of, because I want to practice writing with you. I want to teach you how to write a good explanation for something, because if you can explain something to someone, then you know it. So that is the thing that you're gonna, I'll make this link live later. You know, this will be a live link to a piece of paper. You could click it, print it, copy it yourself on a piece of paper. If you don't have a printer, that's okay. But then after you know, write down your answer nicely, readably, darkly, everything like that, snap a picture, and I'd like you to turn it into a PDF because it's easier to handle, and I'll give you some programs that do that. And then you upload it to the assignments folder on the day due, and once a week, one problem once a week. Not trying to do it by volume. I'm trying to do it by helping you learn to explain things. So I don't need to make you do 20 problems to do that. And if I had the time, maybe I would, but neither you nor I have that time. I'll go into the homework system in a second. Like I said, we'll turn on this written homework tomorrow or the next day. It's due a week from tomorrow. Notice these homeworks are due on Wednesdays always. I'll give you the reason for that in a second. But today your goal is, let's get you into the XYZ homework sometime today during after class, and I'll give you the course code and everything. I'll show you where that is, just so that I know you're in the system. If you do not have a book yet, if you do not have an access pass yet, you can still right now go into the system, set up the account, get into our course and work. They give you like 2-week grace period, 10 days, something like that. Any legitimate system would give you a short grace period. Now you got to deliver and get the book, and you got to buy the access code. Another nice thing about this book and system I really like is, you know, $45 access code, and you have your access to the system and an online copy of the book and access to any book that they create. You know, they want you to practice. Maybe you need to practice something from a previous course. Okay, so this is really kind of an economical and practical system, this XYZ homework. This is the first time I'm using it. I thought it would be really good for the situation, so maybe I'll work out some bugs too. You can tell me if you've come across any bugs, but so far I'm impressed. Down here under handouts, like I said, I'll copy the class session notes. I'll make them a link here. You just click them and you get them. If I take notes in the office hours, I'll cover that access pass in a second. Very good, Amy, thank you. If I take notes in the office hours, and no one was in my office hours today with one exception, then I'll copy them and put them here if you were in the office hour. I do want to apologize to Isaiah. I think you clicked into the office hour like 5 minutes before it started, and I was not at my desk, so I did not see that. The office hour might let you join and wait early, but I was away from my desk till 11:15, and I think Isaiah tried to click in around 11:10. You know, so if I don't respond, come back. I will be there, but I've got, you know, crazy other things to keep track of too. Amy's question to everyone was, you can't do the homework until you buy the access pass. No, you can. All you have to do, and we'll go there, is create the account there. And when they ask you for the access code, you know, if you have one, you input it. But they say, don't have an access code, we'll give you access for whatever it was, 10 weeks. I'm sorry, 10 days, 2 weeks. So you can work today, you can work right now, even if you don't have the access code, but get the book access code purchased either way. Get started in there just so you can send me an email if something's going wrong. But just get into it, get into our class. You don't have to do any of the problems yet if you want to practice some more yourself. but just get started. Class session video is going to be here. Some other recommended problems, like I said, I might create that. I'm going to, after I record these and upload them, they're going to YouTube, and I'll just link you to the playlist in YouTube, okay? So I just like to make things easy to access. I don't know if you guys use D2L e-learning. You'll never find anything I create in e-learning. I do not like putting things behind logins and passwords. I basically teach a lot of classes here. They're all open to anyone, whether they're in the class or not. Of course, you got to pay to get the grades, to get registered for a class, to get a transcript. But I do not put things in e-learning because I don't like it when it goes down. I don't like it when it fails. At least if my website's not working or it's got typos, I can fix it. Okay, so I dump a lot of stuff into Google Drive. I dump a lot of stuff. I'm going to transition even more stuff to YouTube. Okay, thank you, Isaiah. So that is a typical week. Now let's look at the top here. We're doing pretty good on time, but I know that this is not the most exciting thing to do is scan someone else's webpage. Let's go to resources just for a second. Not because there's a lot here, but here's the purpose of the resources page. You're going to want a handout, and you're going to, what week did he do that? What week did we do that? Where is that handout? Week 5? Is it week 6? Oh, click, 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 click. You can do that, but on the resources page, I'm going to collect all the handouts, all the videos, all the copies of notes that we make in class or office hours. That way, you don't have to really hunt for something. You can just go and find it under handouts, video, technology, or exams. I don't have a lot of things posted here yet. You know, an outline of the course, that's not too much. Here's a homework list just showing you when the homeworks are due for the semester. Okay, that's kind of partially useful. When you get in the XY system, you'll see, XYZ system, you'll see the homework scheduled to in a nice calendar. You know, some weeks we got nothing going on, like tomorrow I'm not going to make you hand in anything. Here comes Thanksgiving at 11:25. Well, that's Wednesday before Thanksgiving. So I've got pretty much the schedule listed here, and you'll be able to click on these and see the questions. After they're submitted, you'll be able to see the answers that I post. Notice I said earlier, have everything due on Wednesdays. And the logic here is, apart from next week, all these things are about the previous week. Say, we're covering in this week sections 1, 4, 2, 1, 2, 2, and 2, 3. So we'll finish talking about those basically. Got it. Very good. I'll give you the access code. I'll show you that in just a second. No problem. Basically, we're doing these first 4 sections in the first week, and I set them to be due on the following Wednesday. And the goal here is you're working on them, you're thinking, you're doing. If you want to come back to class on the next Tuesday and ask a question before you do the final wrap up on Wednesday, that's the goal. So all these due dates are set to Wednesday so that you can ask questions if necessary on the Tuesday before they're due, because all of them deal with the material from the previous week. Okay, so then we got notes, we got graph paper. You want some graph paper? Here's links to some graph paper. Whether or not you have a printer, I can understand if you don't have a printer, that may not be so super useful, but during regular classes, sometimes people just print out graph paper that I post in case they want to graph something and they don't want to buy a pad of graph paper. Pad of graph paper is a pretty good investment though. I got other things about examples later. Now, you know, some of these I just haven't cleaned up or organized yet, but sometimes I've got handouts on here like, here's a practice handout for you. Here's the answer. So I do that sometimes. Other examples. Here could be a complete list of videos. just like here will be a complete list of class notes. So you can just go pick up several days at once instead of filing through the weeks. What else is going on here? We got some technology I'll show you in Desmos, or some videos about doing different things. These are pretty much where I want them. On the videos, I'm migrating them to YouTube, and I'm not like super duper proud. Course ID coming up, hang in there. But I'm not trying to be a Hollywood.
Let's do a basic example of completing the square, one that doesn't involve any fractions or radicals. Solve x squared minus 4x minus 2.
I'm not trying to win the Academy Awards here. This video is 1 minute, 35 seconds. It tells you what you need to know on that problem. So you can file through these videos right now. Like I said, I have them hosted on the college server, but I'm going to migrate them to YouTube because I think it's just more accessible. But these are just things I've collected over years. And if you want a new one, ask for it, and we get it. So let's check out the syllabus because that gets you the course code. Oh. Yeah, there are 2 homework assignments, Jacob, and everyone. So once a week, you're going to complete a certain number of sections in the XYZ homework. We'll show you. And you got to work on that. Don't work on it the night before. Work on it during the week, just filling in, doing the problems. But also once a week, I want you to send me a written answer to a problem that I'm going to pick just so I can help you learn to write. So 2 kinds of homework, if you want to say it that way. Let's look quickly at the syllabus. So course instructor expectations grading. You know what course this is. So 119,870. It was scheduled to be face-to-face, Tuesdays and Thursdays, 12 to 2, and the college went online. They said, okay, maybe somebody didn't want to only do an online class and never talk to me. So I just said, we'll keep it at Tuesday, Thursday, 12 to 2. If you're not available, I record. If you are available, you're welcome to come. That's what they mean by remote synchronous delivery. Official course website is right here. You are looking at it. It is not in e-learning at all. Math level 5, appropriate placement. For this class, that means you had an introductory algebra class. And if you're really concerned about, is this the right class for you, stuff like that, talk to me privately afterward, but here's the catalog description. The book, Intermediate Algebra, Turner and McKeague. I like their style, like I said. Here's the number you're looking for. So XYZ homework. You create an account at XYZ homework. You can follow this link. I'll do it in a second. You, at the right moment, give them our course number, 24076. And then you have to activate by entering an access code or going into the free temporary trial. But get that access code. Now, how do you get the access code? If you buy the book, you automatically get the access code. And I will, just for a second, show you what that's what the book looks like. And you get the access code right inside the cover. I can't fit it under my document camera nicely, but just like scratch off, here's the access code. It's in the book. If you buy the book, you get the access code to all of their material automatically. If you don't want a paper book, you can just buy the access code alone, which is slightly cheaper. And then you will be accessing their online book. I always like the paper book because I want to know what happens when my internet goes down. But you can choose which way you want to work. This link will take you to the publisher's website where you can see the book and see the access code. I think Delta College is selling that access code for this. I forgot, was it at 60? But they're selling the book at like $69.50. I don't mind which way you buy it, but at least you have to have that access pass. Comes automatically in the book. So I think the access pass here was cheaper, but the book in the Delta College bookstore was cheaper. But you can check that out and do it the way you want to do it. Okay, back. The XYZ homework system looks like this. If you click into it, and let me expand this window a little bit. Got it. Like I said, I like their attitude. It's not fancy. It's not decorated. It's just, here you go. If you log in, if I log in, let me log out. Now, two things will be different when I log in here. This is what it looks like, but I'll be logging in as the instructor, so my space will look slightly different. Let's not speak my password out loud. You ever do that when you're typing in your password? Say it out loud under your breath. Okay, I have other classes here, but you're interested in Math 119. There's a course code up here, but I've already printed it on my syllabus. And I got a lot more things on the left side maybe than you do, but the key thing is here's the calendar. Here's the sections we're doing. And they're just go through that every day or, once a week, always on Wednesdays. You can work ahead. I think I open these things up like 2 weeks or more before we get to them. You can work ahead slightly, but I don't want you to work ahead and not do the recommended problems and things like that. I want you to notice something that in the homework I gave you, I said 1-4, 2-1, 2-2, and 2-3. Those are what you're going to do on my website. That's what the instructions were. I left 1-1, 1-2, and 1-3 turned on. So that if you wanted to practice some earlier thing, you could, but I'm not counting that against your grade. Also, chapter 1 review, I just left it turned on if you want to practice, but that does not show up in your grade. So what you're responsible for is just the sections I list on my website. And you're going to go into the section and, let's go into section 1.4. And you don't see it exactly like this, and this is a little bit small to read on your screen maybe, right? But there's got 25 questions in there. It sounds like a lot, but first of all, we're just doing some basic computations. So here they're asking for 2 to the power 2, which happens to be 4. And if I do that, somewhere it must have said good deal, Dave. Okay, I got a score of 1 on that. Okay, 1 out of 1. So you can right here click on the book and see examples like this. You can see an example of how to do this. You can, and I told you they were good, you can definitely check out videos. Now, where am I looking right now? I think I'd have to go to the book. Why don't we just experiment? I'd have to go to the book to see videos. Okay, right now you're still on the homework screen. I'm on the book screen. So I'm gonna have to fix that. But you can get some helps while you're in here. But that's roughly what the question was. They're helping you practice basic computations. So this is the first question in the first section, so it's not too involved. Yes, let me. Very good. So let me tell you the purpose of the lay pass. I'm not quite sure what you're seeing yet, but we'll check it out. Anyway, let me go backwards, backwards, backwards. You see the due dates on these right here. So far, no due dates have passed. So technically nothing is late. Let me go back to my website slowly. very slowly. Some of you are already in the system. Thank you for signing out. There we go. Now we're back at my website. You may be asking what I did, and we'll get into this in a second. I don't do things late. I don't take things late, homework stuff, exams, stuff like that. But in their system, what they had set up by default is that you got 3 late passes. I figured, yeah, okay, it's online, things go wrong. I'll leave those turned on. So you probably are seeing, Benito, that it said that you could have 3 late passes in the system. And I don't know, I wrote that somewhere in the website, but I forgot where. So a late pass extends the assignment deadline by 24 hours, if something goes wrong. But that's for the XYZ homework, not for the written homework. Okay. You need a graphing calculator just to help you out. Just graphing calculator, at least always in your pocket. Desmos is a really great tool, and I'll show you some examples later, but you're online in a browser. When you are scanning me a question or sending in a homework, these 2 programs, Apple Notes, Adobe Scan, you can have these on your phone, tablet, whatever. Basically, you take a picture of your paper and it automatically makes it a PDF, and then you can just upload it to your computer and later upload it to my Dropbox, or have it on your phone and then upload it to the Dropbox I demonstrated for you. So I do want you to practice submitting things as single PDF files, but I'll help you adjust to that. I mean, don't send in 6 files, 5 pictures, and 1 written thing and ask me to assemble it. I mean, it's your homework, you assemble it. I'll help you get used to that. But here's 2 quick apps for your phone that could just put everything together very easily. I realize not everybody has access to a printer, so that's what you could do with those phone apps. Who am I? David Redmond. Ordinarily, I'm in my office. I won't be in my office. You probably have to have permission to come to campus anyway. You might be taking a class on campus, but I am not in my office. I am available at these times online. You can also just send me a note, make an appointment, say, hey, are you available at 3 and on Monday? I know I'm in a meeting, but how about 5 or something? We'll find a time. I'll send you the meeting invite, and we'll just connect in a meeting. So if these times are not good for you, we could arrange something else by appointment. Email is Delta College email. That is the easiest way to reach me right now since we're not in offices. And I will use your Delta College email so I don't send it to some crazy other address accidentally. Website, you're looking at it. Office phone, again, I might check my voicemail messages periodically, but I'm not in the office right now. Email is the easiest way to get a hold of me. If you had to mail something, I guess the mail's still running, but you're going to communicate electronically. What are my expectations? First of all, even though email's old-fashioned, it's the way we're going to communicate almost always. And the reason is several classes, several students. I answer your emails quickly, but I do it in the order I get them. And then, so when you send an email to me, it lands in my email box. At least I know, okay, first answer this, second answer this. So I just do things very much in order. And I will use your Delta College email address. Read through the book, the sections that we're going to do that week before we commence on that week. You're not going to understand everything you read, maybe, but you can make notes of your questions. And the idea is, and I'm going to allow this while we're doing the class, if we spend time working on questions, just got my phone hung up in the air there. So, tell me the questions you want to do. We'll do them. We'll do them on the paper. That's going to get them on the paper, copied. It's going to get them in the video. So you read the section ahead of time, and then you've got a list of questions that you want to ask me. Recommended problems I've already talked about. You can have samples of those, but those are just a general test of some of the representative problems in the section. Class sessions, we're doing it. We're going to present material and demonstrate problems, record them, notes, etc. Bring your questions. Office hours, open to all the students in all my courses, and you're welcome at any time. I won't record it, but I will copy the notes. XYZ homework, these are computer-based problems just to help you practice the procedural and computational things. Written homework, I want to work with you so that you get good at explaining things. Exams, we will talk about later, format, everything like that. But let's do things one step at a time. Today, you get in the XYZ homework. Next session, give you a setup for the written homework. And then as the exams approach, we'll talk about them. You need a graphing calculator, yeah, because you just want to learn how to use one in self-defense. And I can show you lots of things on that graphing calculator. And there's probably lots of things on it I don't know how to do. But I can show you how to save some time on it sometimes. You want to learn to draw things accurately and effectively by hand, but you do that by copying what you see on a screen often, carefully. So you're going to practice both with a calculator and by hand with Desmos. But I don't mind if you print out a picture from Desmos and attach it or include it in your homework, unless the homework question says, draw this by hand. So I want you to use the technology. You know that written exercises are submitted into our Dropbox. Just help me, even though this looks weird, when you look at it, just, last name, hyphen, first name, hyphen, homework number, course, just so I don't lose things. I don't lose things, you don't lose things. I got everybody's homework organized because I've got other classes too. So do you. Deadlines, I just set them to 11:59 for every deadline, just so, and principally these are on Wednesdays for the homeworks. So we don't have to worry about any particular time. You get things done on time. Don't wait till the last minute, but you don't have to remember whether that's due at 5 o'clock or noon or whatever. Late written homework and exams, I will not take. Maybe this is what Benito was looking at a second ago. In the XYZ homework system, they had 3 built-in late passes. I said, okay, technology screws up sometimes, so I'll leave those in there. If you're getting ill, if you have any problems like that during the semester, and I suppose they could happen, I've got kids doing the same thing you're doing, just let us know. The accommodations are going to be managed in the Disability Resource Office just because they're used to helping students that, might have an illness or something like that. Grading is short and sweet. You got this XYZ homework, that's 50% of your grade. I want to see that you're proficient at doing calculations. The written homeworks, I want to help you learn how to explain things and prepare you to explain things on a test. So 10%, 20% for each exam. And then I'll just take half of your percentage score there, 10% of your percentage score there. Here's an example. If you had percentage of 86.7 in XYZ homework, etc., for all the stuff, just multiply by 0.5, 0.1, 0.2, 0.2. You got 81.77. Let's just make it simple and call it 82, and that's a B. If you have 81.01, I just put it to the next percentage. It's 82, it's a B. So I want to make this pretty simple to consume. Okay, I apologize for droning on like that. But once you get in to the flow, even if you're not impressed by the flow, once you get into the way we want to do things, you're just going to work smoother. I also forgot to say I don't do anything for more than an hour at a time. So we meet for 2 hours. We're always going to take a break at the top of the hour and just stretch our legs for 5 minutes. I got to do that. You got to do that. Let me check questions. So you have questions, and there are questions going to occur to you 5 minutes from now, and 10 minutes from now, and 5 days from now. Throw some questions in the chat. We're going to take a break in a second and come back in 5 minutes. But maybe there's something I didn't say, or maybe you want me to say something clearer. Let me know. If you ever get kicked out of this meeting, if I didn't say that, you can just follow the link to get it back in, like, you drop the coverage or something in your phone or your computer, internet goes down. You can click the link to rejoin. If my computer freezes or something goes wrong on my end, the Zoom program will try to get you back into the meeting. So if you see my screen freeze or something, just hang on for a second, 30 seconds, a minute. The Zoom program will try to reestablish you in the meeting. So I got to keep my eye on the participant window just in case people drop out and want to come back in. And sometimes I forget to check that while I'm going along here. But I'll do that. I'll keep my eye on that window. And you can help me with that. What I'm going to do now is, when we come back, is I'm going to go through some examples in these sections, maybe 1.4 and 2.1 a little bit. Some explaining, but I think better to explain by doing the examples. So I want to hit these objectives, but I really want you inside their system because he and his team got a lot of videos in there, got a lot of people doing explanations. So I don't want to say like I'm superfluous because the video can't talk back to you. At least I can talk to you. But they got a very nice setup, and that's going to help you out too. So let's take 5. Let's come back at, by my watch, that would be 103. You throw some questions in the chat if you want. I'm going to stop sharing this, and I'm going to mute my microphone. Come back in 5 minutes. Check on any questions you want to ask, and then we'll actually do something. So thank you for being patient. Okay, sorry, I'm back here. Just get my calculator because we'll use that in a second. This is a standard TI-84 calculator, and yours could look a little bit different. On the camera here, it shows up decently, and I can show you pictures, or I can make the pic. I can get it closer there, but you know, if we have to demo how to do something, that's going to work pretty well. You might have one that looks different. You might have one that looks older. You might have one that looks newer. You might have an entirely different graphing calculator. I mean, there's a newer graphing calculator. Draws color pictures. I don't think it's bad. I think it's pretty nice too. Color pictures don't always show up well on this camera, so I don't use this all the time. If you have another calculator, I don't mind at all. I'm going to do the demos on the T84. I don't necessarily know how to use the Casio or the whatever. We could figure it out. I just can't promise you that I could tell you right away. Okay. Let's look at a couple problems in the first section. I could go to my screen too. I'm just going to put this on the paper. Maybe that's printed too small, but I just printed out my own piece of paper and make notes on. Okay, so this is too small to read, so I'm just going to read it at you while we do some example here. But let me check out just a couple of examples here. 1, 4, and 2, 1. Maybe it can't cover everything. We can get you started. And right now I'm just quoting some problems from the book. You know, this is from section 1.4. Say something like number 15. This first section is about exponents in scientific notation. And you may have done some things like this, but I just want to make sure everybody's on the same page. If someone tells you to take minus 5/6 and square it, they literally mean to multiply minus 5/6 by minus 5/6. And it's a positive number. And 5 times 5 is 25 in the numerator. 6 times 6 is 36. But you could also think about it like this. You could think about the minus 5/6 as minus 1 times 5 divided by 6. And to square these multiplied and divided numbers means you're literally squaring each number. When you multiply or divide and raise something to a power, each term, each factor gets that power. And that's another way you could say that's positive 1 times 25 divided by 36. You don't have to write the plus sign if you don't want to. Now, when people get into other problems, it's usually like when they start mixing letters and numbers. You know, like what's 5x cubed compared to 5x cubed? When I write 5x cubed in parentheses, I'm instructing you to cube both the 5 and the x. I'm multiplying here. So it's literally like writing 5x times 5x times 5x. But the effect is just 5 times 5 times 5, x times x times x. That turns out to be 125x cubed. Here, no parentheses. That cube only belongs to the x and to nothing else. So there is nothing to simplify here. This is just a straight 5x cubed. Just picking out some problems at the beginning. If I said 5x cubed times 2x to the 7th, then you bring together the things that belong together. You're multiplying everyone. To multiply the two numbers, you multiply the x cubed and the x seventh, and he gives you the rules for all these exponent laws. But what you have here is 3 copies of x multiplied by 7 copies of x. You have 10 copies of x. You literally add those exponents in that case. And 5 times 2 is also 10. But if I said 2x to the 7th cubed, well, then I got to use another rule. Both people are going to be cubed. And 2 times 2 times 2 is 8. If the number was bigger, I'd use a calculator too. But now I've got x to the 7th times x to the 7th times x to the 7th. I mean, you can literally visualize 3 copies of x to the 7th. And the question is, how many factors of x do you have? 7 plus 7 plus 7, 21. But you don't want to write x7, 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 especially if that number was a 31 instead of a 3. You don't write over 31 copies of this. You just realize that what? When you raise a power to a power, the new power here is multiplying these two powers. In books and stuff, they say it with a rule like that. Or the previous problem, they say it with a rule like this. If you have the same base and you have 2 different exponents and you're multiplying, then you add the exponents. People's problem is not that these rules don't make sense to them, is that when they see this, they do that. And when they see that, they do that. They mix the rules. Don't mix the rules. You got to practice the rules as they are written. Switch paper here in a second. Now, there's other kinds of rules. You wouldn't be surprised if I told you that 3 to the 1st is just 1 copy of 3. So the exponent 1 just means you've got one of those things. What does the exponent 0 mean, though? That's a rule that you have to learn. When you raise a number to the 0 power, you get 1. Because it's like saying you have no factors of 3, but don't call that 0, you call it 1. People also got to get used to having a negative exponent. This is not 3 times minus 2. This is not negative 6. A negative exponent is a signal that they want you to take the reciprocal. So 3 to the minus 2 literally means 1 over 3 to the 2, which you know is 9. So 3 to the minus 2 is 9. Again, you can verify any of these things relatively easily on a calculator. 3 to the 1. Oh, I got to get my thing closer to the light and camera. Okay, 3 to the 1. If it doesn't show up well, just warn me. 3 to the 0. I'm using this key right here with a little pointy thing upwards. It's called a caret. 3 to the 0 is 1. Even the calculator understands what 3 to the minus 2 is. Minus 2 is in the exponent there. Now you get this funny answer, 0.1111111. I expected 1/9, but the calculator doesn't always think in fractions. But I don't know if you know this trick on this calculator. Under the math button, which is right here, my red pen, right there's a math button. If you say math and convert to fraction, that's what that arrow thing is. It'll take your answer and convert it to fraction if it's possible. So 3 to the minus 2 is 1/9. It's a handy button. Not everybody's aware of that button. So here's the basic idea of exponents, but we got to do a serious problem. Now, you know what it means to use positive exponents. You got to keep your rules straight. You got to okay, thank you. That's a perfect example. Thank you, Lily. Yeah, so if you're trying to join and you're not getting into me, I got to work on that. And maybe if you could text someone else in the class and have someone else shoot me a chat in the chat window too. Yeah, phone is not always awesome. It's good for like talking face to face on Zoom, but computer is probably the best experience on Zoom. But what you need to do is to do the problems when I'm mixing variables, numbers, negative exponents, positive exponents. You got to be able to do all the things when the problem gets busy. So let's look at something like 54. And like I said, we'll scan these at the after class is over. So I got 10 a4 b squared over 4 a squared b squared. So it's time for a new rule. What happens if you have 7 factors of b divided by 5 factors of b? Well, then you only have, I don't want to write out 7 b's and 5 b's and cancel them, but I could. But that gets very tedious. You don't want to do that, especially if these numbers are larger. After you cancel each thing that matches, you only have 2 b's left over. But you could realize that, after I cancel 5 b's, I only have 2 b's left over in the top. What happens if you have 13 b to the 13th divided by b to the 16th? Well, here you realize you have 3 b's left over after you do all the canceling, but they're in the bottom. And 1 over b cubed is the signal to write b to the minus 3. Usually you'd rather leave answers with positive exponents. That's the instructions, but if you saw b to the minus 3, you would know what they mean. Even if I said, what's b to the 5th divided by b to the 5th? Well, you say anything divided by itself is 1, and you're right. But you could also think of this as like 7 factors minus 5 factors is 2. 13 minus 16 is minus 3 b's. You could also think this is 5 b's, 5 factors minus 5 factors is 0 factors. That's why people say that something to the 0 power is 1. So you do that here, but you do 3 separate channels, right? B squared divided by B squared is 1. Those perfectly cancel out. You could cancel them here. We're multiplying everybody, not adding. So you cancel them, or you could just write 1 over 1. Here's a to the 4th divided by a squared. There are 2 extra a's in top. And after I cancel these 2 a's out, that would also be a 1 down there. Now be careful, this is not 10 minus 4 is 6. Even this is 4 minus 2 is 2. This is 10 divided by 4. And those are numbers that I have to cancel out, right? 10 is 5 times 2. 4 is 2 times 2. I can cancel something, but I can't cancel everything. What's the answer when I'm done? Multiply everybody. Across the top is 5a squared. Across the bottom is just 2 times 1 times 1. It's a medium problem. I did check that other question in the chat. I'll get to that. Let's look at something like 65. And that is x to the minus 4. This is the test. Can you juggle all the rules at once? So here's how we do it. First, we just take care of the things that are in the parentheses as much as we can first. When you raise a power to a power, you multiply the powers. That was the rule that we gave you right there. So first I want to write this as x to the minus 12. Even this, 3 times minus 4 is x to the minus 12. Then I have a rule that says when I have the same base and I'm multiplying, I add the exponents. That's that rule right there. Add the exponents. Okay, good. I have to check that. I'll go back and do that. Thank you very much. So this is x to the minus 24. And this is x to the 10. Now I'm going to use this rule. I mean, let's say I don't know how many copies of anything I have. You know, the important thing is what's the difference between the m and the n. I just subtract these two. And so I'll go back to the problem maybe that you're asking about this. When I have b squared divided by b squared, it's literally saying b squared divided by b squared is b to the 2 minus 2. But that's just a way of saying no b's, no factors of b. They completely matched and canceled out. 7 divided by 7 is 1. 12 divided by 12 is 1. Anything divided by itself is 1, as long as you're not dividing by 0. So the rule right here is when you divide things with the same base, you subtract the powers. When you multiply things with the same base, you add the powers. So here, I'm going to write x to the negative 24 minus 10, which is a big old minus 34. That's the answer, except the instructions say write with positive exponent only. So people consider it like bad math writing to use a negative exponent in an answer. So you write 1 over x to the 34. That's the rule. A negative exponent means the reciprocal of that power. So your goal is to get all these rules together, practicing them. And I want to hop back to several questions. The question from Jacob about the written homework. That's step 2. So I will post the written homework tomorrow night or before class on Thursday. First step, everybody gets into XYZ. Second step in class next time, I'll show you your first written homework problem. You'll see it. You got 6-7 days to do that. And then it's due in the following week. So hang on to your written homework questions right now. Let me do a couple more problems out of here, and just to carefully make sure we're all on the same page. What if you got something like this? This looks busy. So I've got variables, I've got numbers, some powers here and there, some positive powers, some negative powers. Do you see the second y, the y in the numerator? There's a power there. It's power 1 because y to the 1 is y, but you don't have to write y to the 1. And the variables and the powers, they don't bother me. X squared to the 4th is going to be x to the 8th. The thing that scares me first is the 8 to the 4th, 4 to the 4th. How am I going to do that? Well, the answer is it would be much simpler if you fixed inside the parentheses first. Then did the 4th power for everyone. So in my mind, 8 divided by 4 is 2. 2 in the numerator. X squared divided by x to the 4th. How many x's? 2 extra x's. Where are they, top or bottom? They're in the bottom. There's 2 extra x's in the bottom. Now let's talk about this one. This one's a little bit funnier. 1y on the top, if you want me to write the 1. -3 factors in the bottom, the -3 power. I'm going to use this rule right here. What's y to the 1 divided by y to the -3? By the book, it's 1 minus -3. That is y to the 4th. You could also remember it like this. Negative exponent means reciprocal, means literally that b goes to the other side. So if there's a y to the -3 in the bottom of this fraction, the denominator, that means they really hop to the other side and become 3 y's in the numerator. 1y, 3 y's, 4 y's. 4th power. And now I'm not so upset about raising everybody to the 4th power. I was never going to be afraid of x squared to the 4th. Slide my paper up. That's just x to the 8th. Multiply 2 times 4. Y 4th to 4th is y to the 16th. But 2 to the 4th is a lot better than 8 to the 4th divided by 4 to the 4th. 4 copies of 2. 2, 4. Multiplied by 2 again, 8. Multiplied by 2 again, 16. Verify in your calculator if you like. There you go. There's one other thing I got to show you in this section, but first let me give you, the warning speech. This looks really smooth. And I don't want you to feel sorry for me or anything, but I've done this for 50 years. And I'm talking 50 years. My favorite silly story is when Magic Johnson came into the league with the Lakers, a rookie, awesome talent, Michigan State. Led the Lakers to the World Championship in his rookie year. Well, led along with an awesome team, which included the likes of Kareem Abdul-Jabbar, James Worthy, other people like that. When Kareem Abdul-Jabbar went down before Game 6 against the 76ers, Magic Johnson, 6'9", was slotted in as the center. And if you're not a basketball fan, that's okay. I'm sorry. I apologize. I'll come up with another analogy another day. 6'9" rookie Magic Johnson played center in that game often. Everybody figured Kareem rests, 76ers win Game 6, Kareem comes back for Game 7. No. Magic Johnson as center made a major contribution to that game, and they won the championship in 6 games. Now, what does this have to do with math? The only thing Magic Johnson really had a weakness when he came in as a rookie, he was not a great free throw shooter. Not a great free throw shooter at Michigan State. And in the off season, he knew it, and he practiced. And he came back, and for the rest of his career, his free throw percentage was over 90%, 9 out of 10, 9 out of 10, 9 out of 10. How many years did Magic Johnson play? I have no idea, but I watched all of them when I was growing up. And I don't care how many free throws I saw Magic Johnson shoot. If you give me the ball, I'm going to do 5 out of 10, 6 out of 10, 4 out of 10, 6 out of 10, 7 out of 10, maybe 8 out of 10. In other words, it doesn't matter that I watched Magic Johnson shoot free throws. I can't shoot free throws at that rate. Same thing for you, and it's not a knock. When someone else is doing it, it looks smooth. But if you just watch someone do it, it's not going to help. So you've got to do this yourself. You've got to practice doing all the rules yourself. You've got to practice getting them wrong. You've got to practice missing. Because when you miss, then you figure out how to fix it. So this is way too fast of an explanation. It's not even a good explanation in that sense, but the book and me will try to make a good explanation. You have got to do these by hand, the problems yourself. When you do, you'll see it pay off. But if you don't, you're going to miss things. You're going to miss major things. So get off my soapbox right there. Let me do one more thing related to exponents. And maybe some of you heard this word before, scientific notation. It's a serious pain in the neck to write very large or very small numbers with lots of zeros, like. But you come across this, science book, chemistry book, statistics book. You just come across numbers that are very large or very small. And so scientific notation is just a simple way to write them in a uniform way. This is really 5 times, I got to count here, hundreds, thousands, 100,000, million, 10 million. This is really 5 times 10 million. But 10 million is just a power of 10. So this is one reason why you want to be good at powers. In fact, you get a major break because the powers of 10 have a very simple pattern. Every power of 10 has that many zeros. 2 powers of 10, 2 zeros. So when someone says 10 million and I see 7 zeros, that is literally 7 powers of 10. That's called scientific notation. Move the decimal till you get a number between 1 and 10, and then tell me how many times you had to move that decimal. Literally 7 times. 1, 2, 3, 4, 5, 6, 7 times I moved that decimal. Now, likewise, right here, what I did is move the decimal 1, 2, 3, 4, 5, 6 times, but to the right. This is 3.7 times 10 to the minus 6, which literally means 3.7 divided by 10 to the 6th. 10 to the minus 6 means divided by 10 to the 6th. 10 to the 6th, go through our chart here, is 6 zeros. So 10 to the 6th is 1 million. So this says 3.7 divided by a million, or 3.7 millionths. But if we write it this way, it just gives us a simple way to compare very large and very small numbers. For example, and you can do this on a calculator, but you could do it much faster in scientific notation. What is 50 million times 0.00? 000. I don't even know how to pronounce that. Tenths, hundreds, thousands, 10,000s, 100,000s, millions, 3.7 millions, or 37 10 millions. Written like this, all the zeros are just too confusing. But if you write it with the exponent notation, it gets simpler. Now there's a catch, you gotta be careful. First of all, I'm going to take 3.7 times 5. You know, they belong together. Then I'm going to take 10 to the 7th times 10 to the minus 6th. And that happily becomes very nice. You know, 7 tens, add these two exponents, minus 6 factors, 7 divided by 6 copies of 10, there's only 1 10 left. And 5 times 3.7, I could do that with a calculator without. 5 times 3 is 15, 5 times 0.7 is 3.5. Get out your calculator if you like, but 5 times 3.7 is 18.5. So in plain English, 18.5 times 10 is 185. That's what it means when you multiply these two ugly things. You could write that in scientific notation by saying decimal, decimal, 2 times 1.85 times 10 squared. Let me give you a demo on the calculator. Oops, where did I put that calculator? Yeah, thank you, Ian. So like, yeah, I'll come up with other analogies later, but sometimes they're dumb. Sometimes they make you laugh. The point is when someone makes you laugh, and you know, I'll do my best. It's not hard, not easy to do remotely. When you laugh, you remember something. You remember something that's memorable. And I'm trying to get you to remember something. Anyway, let's see if I can even type this in. 5. How many zeros? 1, 2, 3, 4, 5, 6, 7 zeros. I got to stop shaking the camera. 5. 1, 2, 3, 4, 5, 6, 7 zeros. Yuck. 1, 2, 3, 4, 5 zeros, and then a 3 and a 7. So 0.1, 2, 3, 4, 5, 3, 7. It is 185. But bonus, you can type it in like scientific notation on the calculator. Unfortunately, calculators are like archaic in the sense that there's a lot of leftover old-fashioned notations in calculators. So the calculator doesn't write like this. The calculator writes 5 times 10 to the 7th like this. Sorry. That in calculator language says 5 times 10 to the 7th. It's very, very old-fashioned. It stands for 5 with an exponent of 7, not 5 to the 7th, but 5 times 10 to the 7th. And that key is right here. Oh, I gotta hold it closer. On the comma, it's the, I gotta get it in the light. It's the double E key. That EE stands for inter-exponent. Very, very old school. But some things just persist in the old calculator language. So I do 5, second function, 7. That says 5 times 10 to the 7th. Then I multiply. You know, if I want to make things super extra clear, I'll use parentheses. Now I multiply by 3.7 times 10 to the minus 6. That is 3.7 inter-exponent minus 6. And the calculator responds 185. Now you want the calculator to respond 185 times 10 squared, right? But that would be under the mode button. You could tell the calculator to talk scientific right there. Arrow over, scientific notation. Usually I don't leave it set like that because it's kind of distracting if you're dealing with ordinary numbers. But now I do second function entry. Here's another shortcut. If you do second function entry, you get the last thing you typed. Not everybody knows that one. So that saved me the trouble of retyping. But now that my calculator is in scientific mode, it writes 1.85 times 10 to the 2 in its style. So you can do these things on the calculator too to double check your work. But scientific notation is kind of useful. Try out some of those problems. Okay, I did not give you enough practice with exponents there, not nearly. That's what you're going to do. when you dive into the book and the problems. Okay, just and as a reminder, just you throw questions and comments at the chat window just to get me to stop and pay attention. Just say a word about section 2.1 and maybe we'll do more problems there later. You know, here's 2.1, number 31. It's kind of a small to medium-sized problem. The title of the section is linear equations. This is what people call a linear equation, just a first level equation. You're solving for the number that makes this sentence true. There's lots of numbers you could put in place of x. Like put in 100. But if you put 100 in place of x, you will not get 14. So when someone says solve, or solve for x, what do they mean? They mean find the number that makes the sentence true. And you just do it by following ordinary rules of arithmetic. Combine like terms. Distribute multiplication. Cancel out common factors or divide out common factors. So if I was to do this problem, I'd write 5x plus 4 times 5. 5 times x, 4 times 5. That's called distributing. Now I'm doing this mellow problem for a point, so don't get bored at it. Then I say common term. I have 5 x's, subtract 3 x's. I know how many x's I have. I have 2 x's. And if I want to isolate x further, I want this 20 to move to the other side. I don't move it. I do unto one side as I do unto the other. Kind of like the golden rule of math. So 2x now is minus 6. Here's where I used the word canceling a second ago. There's a 2 on the left. There's a 2 on the right. It's hidden. 6 is 3 times 2. I could say cancel, or I could say it like this. Let's divide both sides by 2. And then I know that x is minus 3. I want to make sure I didn't screw up, so let's try it. He doesn't always say this in the book, but if you have time, you always check stuff. Let's put minus 3 in here. What's minus 3 plus 4? That's 1. What's minus 3? Careful now. Minus 3 times minus 3 is positive 9. Is it truly 14? 5 plus 9 is 14. I'm happy. It doesn't take you a second to check things. You should check things. Sometimes it's more complicated to check, but if you can, check, because, you know, why take a gamble on the answer? Why not just know you're right? Here's what I want to say to you, though. A lot of people look at that problem and say, oh yeah, that's easy, I can do those. But then they'll break into a sweat if I write the problem like this. Sorry. Now I changed several things. I changed the 14 to a 15, but look at the problem about 5x plus 4 minus 3x equals 14. You practice those like that, and pretty soon you'll say, yeah, no problem. I got it. But if I just do something silly, like take 1 over 5 instead of 5, instead of multiply by 3, divide by 3, instead of 14, I say 1 over 15, then people panic. And why do they panic? Because you don't enjoy doing fractions, right? 2 plus 3 is 5. That's easy. What's 1/2 plus 1/3? Well, it's not that you can't do it. It's just that you have to think about it. Literally, you have to make common denominator of 6. Then you know that it's 5/6. Isn't that interesting? Do you see that it's still 2 plus 3 in a way? This is a small problem, so that's not the way it always happens. It's still 2 plus 3. It's still as simple as 2 plus 3 equals 5. But you had to do an extra step. Now here we go on this. Say you got this problem right here. Scary looking. But if you do one beginning step, then you don't have to look at the fractions anymore. You can use fractions. You could get common denominators, and the common denominator here is not terrible. It's 15. You could multiply this top and bottom by 3 to make 15ths. Multiply this top and bottom by 5 to make 15ths. But, and I don't think we have too much time for more than this example, if I, instead of making common denominators, I hate fractions. I don't want to deal with fractions when I don't have to. If you multiply by the least common denominator, you can change the problem so that it looks like that problem. Kind of. Now, the catch is you have to multiply exactly correctly. And people are in a rush all the time, right? So let's multiply both sides by 15, the least common denominator. But let's do it super legal-like. And the reason why people don't like to do it carefully and legal-like is they look at the easy things and say, oh yeah, that's a 1. I don't have to write that down, that's a 1. Okay, did it cost you to write down 15 times 1 over 15? Did it cost you 2 seconds? When you get super good and you can do everything in your head, then more power to you. But right now, why don't you just write down what you're doing? It doesn't cost you much time. Now let's practice multiplying. It is just distributing. 15 times 1/5 times x plus 4. Now you could look ahead at this and say 15 divided by 5 is 3, and I will say 3, but I am not in a hurry. 15 times 1/5 is 15 divided by 3. At the next step, I'll say 3. You say 3x plus 12. I say, no, that's the next step. Just do one thing at a time. Now multiply 15 times minus x over 3. Again, the 15 divided by 3 is easier. Built to cancel. 15 divided by 3 is 5. So this is just minus 5x. But I got to respect that sign, and I got to respect that these are 2 separate multiplying, so I get 2 separate cancelings. Now it looks like that problem. Now I allow you to say, yeah, I can do that. That's easier. I still have to obey the rules, right? Still have to say 3x plus 12 minus 5x is 1. 3x's minus 5x's is negative 2x's. 12 subtracted from both sides is minus 11 on the left. I didn't say the answer is going to be pretty, but I can divide both sides by minus 2. Minus 2. X is negative divided by negative is positive. 11 halves. You could say 5 1/2, but no one's going to harm you if you just say 11 halves. I don't mind if you say 5.5. I don't mind if you say 5.5, really, but usually these things are extra work. 11.5 is fine. Now, there's no way, this math teachers annoy the heck out of people when they say, what's your problem? This is the same problem. Why do you think the bottom one is worse? Because the bottom one is worse. So it's very annoying when the math teacher says, it's the same problem. Just go ahead and do it. It's the same problem. No, I had to do something else to prepare this. As long as I'm just careful and practice a lot, I can do it. And then when I get down to here, I say, I kind of groan and say, yeah, it's the same problem. You're right, it's the same problem. So you want to see the answer right here. 11/2 is the answer. And remember, I will scan this and the recordings are going to be posted. Now, I'll tell you something. Do you have a doubt in your mind? What's it going to cost you to check it? Because it's a fraction, you're not going to enjoy it. But let's just try it. 1/5, 11/2. I'm putting this back into the original question, and it's kind of, I have the original question up here, so I apologize. In the recordings and in the copy, you'll see the original question. I'm going to write 4 as 8/2, because that's 8/2. 11/2 divided by 3 is 1/15. So I've got 1/5 times 19/2, yuck. Here, think of 11/2 divided by 3 as like 1/3 of 11/2. In other words, this 2 belongs in the denominator. Dividing by 3 is multiplying by 1/3. So 1/3 times 11/2, 11/6. And still, you don't have too much hope for this. But let's hang in there. 19/10 minus 11/6 is 1/15. I don't know. Let's go for common denominators. 30 multiplied by 3, 57/30. Multiplied by 5, top and bottom, 55/30. And then the magic happens. It's 2/30, which is 1/15. Now that check cost me, that wasn't 2 seconds. That was 45 seconds, 60 seconds. Okay. Check things when you have time. If you're trying to perform a test for someone someday, you're carefully, quickly working out the answers. If you have time to check, you go back and check. If you have the homework, you often have time to check, but you got other homework to do. I understand. When in doubt, check. When you can, check. And once you've checked, you got some peace of mind. Some people say, oh, looking in the back of the book, that's checking. It is. It's looking at the answer in the back of the book. And 99% of the time, the answer is right at the back of the book. Sometimes it's wrong. Checking is showing someone that your answer is right. Not just saying you agree with a fancy person who wrote the book, who might be wrong. So remember, checking is actually showing that your answer is right. Okay, we want to do 4 sections this week. 1, 4, 2, 1, 2, 2, 2, 3. I could say some more things about 2, 1. We spent a lot of time just getting a common foundation. So it wasn't exciting, but I'm not going to apologize for it either, because get everybody on the same page is good. You could check that with a calculator. That's a very legitimate question. I will not stop you from checking anything with a calculator. Sometimes, if the answers are crazy fractions, then the calculator wants to talk decimals. And that makes it harder to compare some things, but you can always check with a calculator, and at least that give you like 99.999% satisfaction. Making a decimal joke right there. So I don't mind if you check with a calculator at all. This just helps you practice fractions. Okay, what I'm going to do right now, I'm going to call it quits. I'm going to stop the recording. I'm going to say goodbye. I'm going to process the recording, post it to YouTube, link to my websites. If you come back to my website in a couple hours, everything should be linked up and posted. Now, I don't know what's on my schedule for the rest of the day, so maybe it's later tonight. But we got a flow. We got a plan. We got a way we do things. You'll see this recording later. Is there any, you can always shoot me questions in email and I'll answer them there too. But is there any kind of quick question I can answer for you here? And I don't mean to not make you talk. I mean, you can talk out loud if you want to. I will be putting it in, just to remind you, in our week 1, you go to video, and it will show up right there, September 1. But as things go on, you want to look at more resources, video, class sessions, video class sessions. Yeah, I love bulleted lists, right? I love making lists of things that I'm supposed to do and I never finish doing. So here's a list of the class session videos. They'll be on every week's page and they'll be on the resources page. So good question, thank you. Okay, I'm gonna stop sharing the screen. I'm going to stop my recording and say goodbye. You guys have a great day. Go outside because the weather turned a little bit nicer. And I'll check back in with you on Thursday. You guys have a nice day.